The desert remembers everything. Beneath the endless dunes and the whisper of the wind lies a silence older than history, a silence built from stone, mathematics, and faith. Egypt is not just a land of monuments, it is a vast archive of experiments in geometry, engineering, and human ambition. From orbit, satellites now scan the ground where the Nile once shifted its course, revealing faint lines of forgotten walls, buried roads, and symmetrical voids that stretch across hundreds of kilometers. These are not random patterns of erosion. They are the fingerprints of the world's first engineers, people who saw the planet itself as an instrument to be tuned. For more than 4,000 years, their machines have slept under the sand, vast, silent, and indestructible. They built no gears, forged no steel, and yet their creations endure when empires have crumbled to dust. To the modern eye, these monuments seem miraculous. To the ancient mind, they were mathematics made visible systems of stone that mirrored the rhythm of the cosmos. And now, as radar, LiDAR, and cosmic particle scans pierce the ground beneath Giza, the truth begins to surface. Egypt's great monuments were never lifeless tombs. They were living equations, vast machines of balance, resonance, and time, built to last not for centuries, but for eternity. There are places in Egypt where the desert seems perfectly still, as if time itself has chosen to sleep beneath its own dust. Yet from hundreds of kilometers above, satellites have begun to see what the human eye never could. Through radar and infrared mapping, through LiDAR and multispectral imaging, they have revealed faint outlines beneath the dunes' geometric forms where none should exist. Buried corridors stretching for kilometers under the Sahara, and dark shapes beneath the fertile line of the Nile Valley that may once have been temples, workshops, or entire cities erased by the centuries. The Earth remembers everything. Even when wind covers it, heat leaves signatures. Synthetic aperture radar can read those differences, subtle changes in soil density or moisture that trace the ghost of a wall or a buried foundation. Over time, millions of such signals have accumulated into patterns that archaeologists now study like star charts. Across the landscape of Egypt, the sand itself is a map written in layers of frequency and light. Deep in the laboratories of the Egyptian Ministry of Antiquities, screens glow with these new images. Each scan is a whisper from the ground. Some show ancient riverbeds that once flowed where desert now reigns. Others reveal long-lost roads radiating outward from the Nile like the veins of a living organism. Even the Great Pyramids of Giza, long thought to be fully explored, reveal new anomalies, hidden cavities, chambers, and linear voids that seem too precise to be random. The technology that uncovered them is as advanced as any tool of modern physics. Ground-penetrating radar sends electromagnetic waves through the sand and reads their echo. LiDAR, short for light detection and ranging, sweeps the surface with laser pulses that build a digital model accurate to within centimeters. And most recently, muon tomography, the same method used to study volcanoes and nuclear reactors, counts the subatomic particles that rain down from the cosmos and pass through stone, revealing voids by their absence. Each of these techniques peels away another layer of invisibility. To many, this might seem like magic, but it is measurement. The same laws that describe the expansion of galaxies can be used to map a burial chamber beneath a pyramid. It is all physics, scaled from the infinite to the infinitesimal. Muons, born in the upper atmosphere, travel through kilometers of rock at nearly the speed of light. When they pass through dense granite, fewer reach the detector. When they pass through empty space, more arrive. From those differences, an image forms a shadow of what lies hidden within. The discoveries made by these invisible eyes have rewritten the boundaries of known Egypt. Beneath the desert around Saqqara, beneath the cliffs of Abydos, and under the unassuming plains of Fayum, structures emerge that no one has entered for thousands of years. Some are simple tombs. Others are so complex, so mathematically aligned, that even archaeologists accustomed to wonder pause in disbelief. Their corridors seem to converge toward unseen centers, their angles calculated with impossible precision for an age of copper and stone. It is here that science meets awe. The more we see, the less we understand how such works were conceived. The ancients built as if guided by geometry itself. The lines of their monuments echo the stars, the river, and the solstice Sunday. Every alignment suggests intention. Yet for all our instruments, for all our equations and data streams, we still cannot easily grasp the full system that once pulsed beneath this land. Under these sands, the silence is not empty. It is dense with memory. Somewhere beneath the dunes near Abu Rawash, radar images show a network of trenches that may have held ancient machinery for moving stone. Near Dashur, LIDAR has uncovered a pattern resembling ramps, converging toward a foundation long destroyed. And under the vast expanse west of the Nile, muon data indicates voids beneath collapsed mastabas, possible tunnels or air shafts never documented before. Egyptologists have begun to speak of a second landscape, one that exists below the visible one. It is as real as the pyramids, yet composed entirely of data, a digital necropolis suspended between light and sand. Every scan deepens the mystery. Every discovery expands the question. How far down does the civilization of the pharaohs truly go? What remains untouched by the pick and trowel, unseen by drone or satellite, still preserved in the dry vacuum of the Sahara? Those who work on the ground know the scale of this challenge. The desert's surface covers more than 1 million square kilometers, and only a fraction has ever been excavated. Each new survey reveals more than it explains. In some areas, like the Baharia Oasis, the sand hides entire necropolises that stretch beyond the reach of current exploration. In others, beneath the shifting dunes of the Western Desert, what appears to be natural geology forms geometric arrays, rectangles and corridors repeating at precise intervals, suggesting deliberate construction far older than recorded dynasties. To the untrained eye, the desert appears lifeless. To instruments tuned to light and magnetism, it is crowded with echoes of lost labor. Ancient walls re-radiate heat differently than surrounding sand. Buried stone alters the magnetic field. Even broken pottery, dispersed through centuries, changes the reflectivity of the soil. The instruments capture these differences and weave them into images. And through those images, the voice of ancient Egypt speaks again. But perhaps what matters most is what these discoveries imply. Beneath the surface of this civilization, beneath its temples and monuments, lies an infrastructure of extraordinary design. What we call ruins were once parts of systems coordinated, measured, engineered. These systems allowed stone blocks weighing hundreds of tons to be moved, lifted, and set with millimeter accuracy long before the concept of machinery as we know it existed. The sand is not just a burial ground, it is a vast archive of engineering. And so, as satellites pass over Egypt each night, gathering faint reflections from the earth below, they are not merely mapping terrain, they are scanning time itself, peeling away centuries of silence grain by grain. Each image brings us closer to understanding how an ancient society, armed with simple tools and boundless intellect, shaped the physical world into an extension of its mind. Under these sands lie the remains of the world's first engineers. The desert at dawn is deceptive. What appears as an endless emptiness is, in truth, a tapestry of signals waiting to be read. When the sun climbs low over the horizon, its rays skim the sand at shallow angles, revealing faint ridges that once were walls or causeways. Archaeologists walk this shifting terrain guided not only by their eyes but by devices that listen to the ground. A pulse of radio energy, a flash of infrared light, a vibration measured by a buried sensor. All of these are the modern extensions of curiosity that once drove ancient hands to carve stone. Beneath the calm horizon of the Sahara, the soil itself is layered with history. The Nile has changed course countless times over tens of thousands of years, leaving behind sediments that bury and preserve. Each flood deposited clay and silt that sealed old settlements beneath new fields. When viewed from orbit, the Nile Valley is a bright ribbon of life against the darkness of the desert. Yet even within its fertile edges, towns and temples lie hidden beneath layers of time thicker than any pyramid block. The very fertility that sustained Egypt also entombed its earliest works. Modern sensors see through that veil. Infrared imaging detects differences in temperature as the soil cools after sunset. Ancient stone absorbs heat during the day, and releases it slowly at night, creating thermal shadows that satellites capture from above. In these thermal maps, forgotten architecture glows faintly, like embers beneath ash. The shapes often align with known patterns: long, straight lines for causeways, rectangular outlines for storage chambers, and circular depressions for wells and grain silos. Sometimes, the discoveries are stranger still: concentric forms in the sand whose symmetry suggests a purpose lost to history. The power of such technology lies not only in revelation but in restoration. By combining radar, LiDAR, and muon data, researchers can reconstruct entire complexes without lifting a single grain of sand. In laboratories across Cairo and Paris, digital models now exist of cities erased 3,000 years ago. Computer simulations trace ancient water channels, showing how engineers may have redirected streams to cool or float stone during transport. Artificial intelligence, trained on known ruins, searches for patterns in satellite data and finds others that human analysts might overlook. The result is a digital resurrection of Egypt's buried infrastructure, one pixel at a time. Yet, technology alone cannot interpret what it sees. For every discovery, questions multiply. Some structures appear older than the dynasties that history records. Under the dunes west of Luxor, radar scans suggest foundations lying beneath later temples. Were these earlier experiments in architecture, or do they belong to an era before writing, when memory itself was the only archive? The desert offers no easy answers, only hints shaped by wind and time. To understand these buried machines of stone, we must look not only at what they built but how they thought. The builders of ancient Egypt were not improvisers. They worked within a system of geometry so consistent that even their smallest shrines align with the cardinal points. Their tools may have been simple copper chisels, dolerite pounders, ropes, yet their understanding of structure and balance reveals minds as disciplined as any modern engineer. Each scan beneath the sand exposes evidence of this discipline: perfectly level foundations, right angles maintained over vast distances, corridors whose slopes follow precise ratios. In the 21st century, when scientists apply physics to archaeology, they begin to see the same logic that governs the cosmos mirrored in the plans of these ancient structures. A pyramid's weight distribution follows the same mathematical curve as a stable mountain slope. The orientation of temples to the rising sun mirrors orbital calculations used in modern astronomy. To call these coincidences is to underestimate a civilization that observed the heavens every night for millennia and built its calendar upon the motion of the stars. The more we measure, the more we realize that Egypt's builders treated stone as data matter, encoded with information about proportion, resonance, and cosmic order. The monuments we see are the visible interfaces of systems that extended underground and across the landscape. Channels, pits, and chambers beneath the surface may have regulated airflow, water movement, or ceremonial sound. In the Great Pyramid alone, muon scans reveal voids aligned in ways that suggest function rather than accident. Some archaeologists interpret them as structural, relieving stress from the massive core. Others propose they once formed a mechanical sequence, a counterweight system designed to move stones upward with minimal human force. It is easy to romanticize such theories, but caution is essential. The evidence must guide the imagination, not the reverse. Where speculation begins, the truth must follow close behind. The machines buried beneath Egypt's sands were not engines of steel or wheels of bronze. They were organized systems, human, geometric, and physical. Each worker, each tool, each stone played a role in the great mechanism of construction. When we uncover these buried ruins, we are not finding remnants of technology in the modern sense. We are finding the physical manifestations of collective thought. In the silence of the desert, that thought still vibrates. The air above Giza hums faintly at night as wind moves across the precise faces of the pyramids, producing tones that shift with temperature. To some, these sounds are natural. To others, they are the lingering resonance of design acoustic engineering encoded in limestone. Sound, after all, was sacred to the Egyptians. They believed the universe itself was spoken into existence. If so, then their monuments were not only tombs but instruments, tuned to the frequencies of creation. As the scans grow clearer and the maps expand, the line between myth and measurement blurs. The sands reveal not fantasy but evidence of a civilization that understood its environment with astonishing depth. They harnessed sunlight, water, and gravity as natural machines. Their tools were extensions of the laws of physics, and beneath every dune, more of those tools remain waiting to be found. The world now watches Egypt from space, from aircraft, from the ground with instruments finer than any chisel. What we discover is not the past but the continuity of curiosity itself. Every satellite, every probe, every archaeologist kneeling in the heat is part of the same lineage that once measured the stars to guide the river's flood. Beneath the sands of time, we are not only finding them, we are finding ourselves. The night air over the Sahara cools quickly, and when darkness settles, the heat stored in stone begins to radiate into the void above. To sensitive instruments orbiting hundreds of kilometers away, this nightly breathing of the earth is a signal. It outlines the hidden shapes of Egypt's ancient past more clearly than daylight ever could. Each thermal pulse marks the edge of a buried wall, a corridor, or a chamber long forgotten. The ground glows with the memory of architecture, a cartography of heat drawn by time itself. Archaeologists now work between worlds, part scientist, part explorer, part translator of shadows. Their camps near Saqqara hum with low generators powering laptops and radar screens. They rise before dawn to walk the dunes, guided by coordinates drawn from data gathered in orbit the night before. A sweep of a handheld radar antenna sends invisible waves through sand that has not felt human touch in thousands of years. On the display, faint curves appear. A right angle emerges. Beneath the surface lies structure, deliberate, and human. When the first LiDAR scans were released from southern Egypt, researchers noticed something remarkable. Beneath the modern town, boundaries lay entire street grids from an earlier era, perfectly aligned with the cardinal directions. The discovery forced historians to reconsider how deeply organized the ancient builders had been. Their cities were not chaotic clusters, but systems of geometry, each part fitting the next like teeth in a vast unseen gear. Beneath the sands, these invisible grids speak of planning on an industrial scale. To understand what is buried, scientists now combine multiple kinds of observation. Magnetometry detects faint disturbances in the planet's magnetic field caused by buried stone or metal. Gravimetry measures minute variations in density beneath the surface. When these datasets are layered together, they reveal cross-sections of ancient Egypt that stretch vertically and horizontally through time. What emerges is a civilization seen not as a collection of monuments, but as an interconnected organism of stone, water, and labor. Some of the most intriguing findings come from the Western Desert, where radar imagery shows patterns inconsistent with natural dunes. The lines run straight for hundreds of meters, sometimes intersecting at precise right angles. When examined with higher resolution sensors, they resolve into corridors leading towards central voids. Some researchers believe these could be the remnants of lost quarries or ceremonial enclosures. Others suspect early experiments in subterranean construction, precursors to the grand tombs that would later dominate the Valley of the Kings. The deeper the data goes, the stranger the picture becomes. Beneath the plateau of Giza, muon detectors placed inside existing chambers have revealed at least 2 unknown cavities, one of them the size of a small aircraft hangar. The detectors register subtle differences in cosmic ray absorption, tracing voids invisible to any other tool. No one knows yet whether these spaces served a structural purpose or if they were once part of a mechanical system designed to move air, water, or counterweights within the pyramid's mass. The evidence remains tantalizing but incomplete, suspended between science and speculation. Still, the implications are profound. If such systems existed, they would represent the earliest known examples of mechanical engineering on a monumental scale. Even without metal gears or engines, the builders of Egypt might have created dynamic systems, weights, levers, and channels that used natural forces to move unimaginable masses. In this sense, the desert itself becomes a machine, a landscape shaped to perform work, powered by gravity, sunlight, and human coordination. Walking across those same dunes today, one can feel the weight of that ingenuity. The ground crunches underfoot with fragments of quartz and flint. A breeze carries the dry scent of limestone dust. Somewhere beneath, shafts descend into darkness. Instruments show cavities but not their contents. Perhaps they hold only air and silence, or perhaps they preserve the remnants of tools, pulleys, or ramps, the skeletal traces of forgotten experiments in motion. Every step is a reminder that the frontier of discovery lies not in distant galaxies, but under our own feet. When ancient builders looked at this same horizon, they must have seen more than desert. To them, the sand was potential energy waiting to be shaped. Each dune could be leveled, each stone measured, each shadow aligned with the path of the Sunday. Over centuries, those visions solidified into architecture. Now, millennia later, technology allows us to reverse that process, to see through the sand back into the minds of those who imagined it all. The story of Egypt is not frozen in the past. It continues to evolve with every scan and every measurement. Each new discovery reveals not only what they built, but how they thought. It is a dialogue across time, carried by the same curiosity that once pushed ancient engineers to test the limits of stone and balance. Their monuments were equations written in limestone, solved by light and shadow at every sunrise. What lies beneath the sands is not only the foundation of Egypt, but the foundation of human intellect. The same principles that drive our machines today, energy, leverage, alignment, were already understood in spirit by those who raised pyramids against the sky. In rediscovering them, we rediscover ourselves, our hunger to understand and to build. And so, the satellites continue their orbits, the muon detectors continue their count, and the wind continues to erase and reveal, grain by grain. Beneath the sands of time, the first engineers still wait, their blueprints written not on papyrus but in the very bedrock of the earth. Their legacy whispers through the data, through the silence, through the endless dunes. The machines of ancient Egypt are still there, sleeping, waiting for the moment we are ready to see them for what they truly are. In the silent heat of Upper Egypt, the quarry of Aswan glows like a mirror. Pink granite reflects the light of the morning sun, its surface pitted with marks that seem to pulse with history. The stones here were once alive with sound, the ring of copper on granite, the low thud of dolerite pounding stones, the rasp of sand grinding under wooden saws. For centuries, these quarries were Egypt's true workshops, the hidden factories that supplied the raw heart of civilization. The workers who shaped this landscape were more than laborers. They were machinists of the natural world. Their tools were primitive in appearance, yet what they achieved defies the imagination. A single unfinished obelisk still lies embedded in the bedrock at Aswan, weighing more than 1,000 tons. It cracked during carving and was abandoned where it lay. Along its sides, the marks of copper chisels and pounding spheres are still visible, as clear as fingerprints. When examined closely, the striations reveal astonishing regularity. Every groove was measured, every strike repeated with metronomic precision. These were not random blows, but the calculated rhythms of ancient engineering. Archaeologists have long debated how such hardness could be mastered with tools of simple copper. Copper, soft compared to granite, should have bent or dulled in moments. Yet the Egyptians persisted, using abrasives such as quartz sand and the natural hardness of dolerite to wear down the stone grain by grain. It was not brute force that moved mountains here, but patience harnessed through geometry and rhythm. Every pit, every tool mark is a record of physical reasoning. In the nearby desert, archaeologists have uncovered ancient copper smelting sites. Charcoal remains, slag, and crucibles show that metal was produced in quantities sufficient for entire construction teams. The furnaces were lined with clay and bellows fed by reed pipes. Workers learned to control airflow and temperature so precisely that they could separate copper from ore with remarkable efficiency. The chemical mastery required for this process is no less impressive than the physics of their architecture. The Egyptians knew how to tame both fire and stone. When the sun sets over these quarries, the air cools and silence returns, but the landscape retains the geometry of production. Grooves, trenches, and discarded tool fragments tell a story older than any written record. Each depression in the granite floor corresponds to a specific tool motion, repeated over days, months, or even years. These were assembly lines before the concept of a factory existed. The men and women who worked here were part of a vast mechanical system powered by human endurance and guided by mathematics. Farther north, at Tura and Mokattam, other quarries supplied the fine white limestone used to sheath the pyramids. These blocks were cut with astonishing uniformity, their faces polished until they gleamed like sunlight itself. The method was simple, yet profound. Copper saws, strengthened by adding traces of arsenic and lubricated with water, cut through limestone with the help of sand abrasives. Over time, as the saws moved, the abrasive grains carved the rock like microscopic teeth. What looks to us like impossible precision was the cumulative effect of millions of controlled motions guided by knowledge passed down through generations. The Egyptians treated every stage of construction as a sacred ritual. Cutting stone was not merely labor, it was an act of transformation, turning raw earth into a vessel for eternity. In their worldview, each stroke of a chisel was a dialogue between human intent and divine material. Even the simplest worker understood his place within a cosmic mechanism, a system where matter, mathematics, and spirit converged. The workshop was not separate from the temple, it was its foundation. Evidence from excavation sites near Saqqara shows that these quarries and workshops were connected to major construction zones by roads paved with limestone chips and compacted clay. Along these paths, archaeologists have found fragments of copper chisels, hammerstones, and fragments of tubular drill cores. The drills are among the most fascinating artifacts ever discovered. Hollow cores of granite or basalt show spiral striations that suggest the use of bow-driven tubular drills with quartz sand as the cutting medium. The rate of penetration achieved by such tools is difficult to reconcile with modern expectations of copper's softness, leading to endless debate among engineers and historians. Yet experiments reproduce similar marks when sand is used correctly. The process was slow but inexorable friction doing what sharpness could not. These discoveries paint a picture of Egypt not as a culture of static monuments, but as a living engine of innovation. Each quarry, each forge, each workshop was part of a distributed network of production. From the smelters of Sinai to the polishing floors of Giza, the civilization functioned as one continuous factory stretching the length of the Nile. Workers, artisans, engineers, and priests all contributed to an invisible system of coordination that allowed millions of stones to be cut, shaped, and placed with breathtaking speed and precision. Even today, when modern builders attempt to replicate the fit of pyramid casing stones, they find themselves humbled. The joints are so fine that a blade of grass cannot fit between them. Yet there is no evidence of iron tools. The technology was knowledge itself, an understanding of geometry, leverage, and materials so complete that it became indistinguishable from magic. In the dim light of a quarry tunnel, one can almost hear the rhythm of that ancient labor. The clang of copper against granite echoes like a heartbeat from another age. Sparks flash in the imagination, and the air seems filled with dust and purpose. These were Egypt's true machines, not engines of metal, but human systems of precision, discipline, and shared intent. Every mark in the stone is a data point, every groove an equation solved by hand and eye. When the Nile flooded each year, work would pause, the quarries would cool, and the workshops would fall silent. But as soon as the waters receded, life resumed in a pattern as reliable as the river itself. The Egyptians lived by cycles solar, lunar, and hydraulic. Their engineering reflected that rhythm, translating cosmic order into practical design. The quarries and smelters were not isolated facilities. They were expressions of a worldview in which creation was a continuous act. The evidence we uncover today confirms what ancient texts only hinted at. Egypt was not merely a civilization of kings and tombs, but of engineers and thinkers. Their lost workshops were laboratories of experiment, refining techniques that would shape the next 3 millennia of architecture. They mastered the physics of friction, the chemistry of metals, and the geometry of alignment. To call them primitive is to misunderstand the nature of genius. They were not working toward modernity. They were inventing permanence. As night falls over Aswan, the granite cools and stars appear above the horizon. Somewhere beyond that darkness lies the memory of a people who transformed raw matter into timeless form. Their tools have rusted away, but their precision remains carved into the living stone of Egypt. These were not the artisans of myth, but the first true machinists of human history, and their legacy is still buried in the quarries, waiting for the next beam of light to uncover what time itself could not erase. The moon rises slowly over the cliffs of Aswan, pale and silent against the vast darkness of the desert. Beneath its cold glow, the scars of the ancient quarries shimmer faintly, like veins in the flesh of the earth. Each pit, each chisel mark, each half-finished block is a record of both triumph and exhaustion. The air is so dry that the copper dust still lingers in the cracks of the stone, a reminder of the hands that once wielded it. In this lunar light, the quarry becomes something more than a place of labor. It is a monument to precision, an outdoor workshop where humanity first learned to think mechanically. The people who worked here did not see themselves as artists, but as servants of order. To them, geometry was divine law. Every surface, every line, was measured against the cosmos. They used simple ropes stretched between wooden pegs to draw perfectly straight lines, and they leveled their work by floating small vessels of water to find true horizontals. From such modest instruments came precision that astonishes even now. In a world without steel or electricity, they achieved tolerances that modern engineers struggle to explain. Along the Nile, archaeologists have uncovered entire districts dedicated to craft and metallurgy. Near Giza, layers of ash and slag reveal the presence of vast workshops where copper was smelted and cast. Clay molds found among the debris show that chisels and saw blades were produced in enormous numbers. Some molds bear marks suggesting serial casting, as though they were manufacturing tools in batches rather than individually. In every sense, these were the prototypes of industrial production factories, long before the industrial age. In one such site near Saqqara, excavators uncovered a chamber lined with discarded tubular drill cores. Each core was a cylinder of hard stone, drilled clean through by a hollow tube tipped with abrasive sand. The striations spiraling along their inner walls are so regular that they resemble the threading of a modern machine part. For decades, debates have raged about how such marks could be made by hand. Some claim that these were produced by continuous rotation with weighted bow drills. Others suggest mechanical advantage using counterweights or water power. Whatever the method, the evidence speaks for itself: precision that cannot be dismissed as coincidence. Copper alone was not enough to achieve this. The Egyptians exploited materials in ways that bordered on alchemy. They mixed copper with small quantities of arsenic and tin to create harder alloys. They understood that sand, when moved under pressure, could cut anything, even granite. They discovered that dolerite, harder than the stones they carved, could serve as a hammer capable of fracturing granite without shattering. Their technology was not dependent on advanced metals, but on advanced understanding. Every fragment found in these workshops carries a trace of that intellect. The pounding stones are worn smooth on one side, suggesting a standardized motion used across generations. The chisels are uniform in size, their edges reforged and resharpened countless times. The discarded fragments of saw blades are bent in identical patterns, evidence of stresses measured and managed. Nothing about this was random. Everything obeyed an internal logic, as if guided by an invisible engineer whose blueprints were drawn in the minds of thousands. When modern scientists study these traces, they find patterns that mirror our own manufacturing principles. The spacing of chisel marks follows harmonic intervals that reduce fatigue. The layout of quarry trenches allows debris to fall naturally into removal channels. Even the sequence of tool usage follows what we would now call process optimization. Yet there is no record of written manuals or diagrams. The knowledge was transmitted through apprenticeship, gesture, and repetition, a living database encoded in muscle and memory. In the heart of one quarry, archaeologists found something remarkable. A set of parallel grooves cut deep into granite, so straight and evenly spaced that laser measurements show deviations of less than a millimeter over several meters. To the human eye, they appear flawless. The grooves stop abruptly, as though the work has vanished mid-task. Around them lie fragments of copper saws and pebbles of quartz sand, still glittering after thousands of years. This unfinished section is a time capsule, frozen at the precise moment where human ambition met the limits of endurance. The process of shaping such immense stone required more than technique. It required orchestration. Teams of workers alternated shifts, hammering in rhythm to maintain uniform impact. Overseers marked progress with pigment lines on the rock, recording how far each day's labor had advanced. The rhythm of these blows would have echoed across the valley, a mechanical heartbeat that never ceased. In that sound, one can almost hear the pulse of civilization itself, the synchronization of effort and purpose that transformed raw landscape into structure. Beyond the physical evidence, temple reliefs and wall paintings give glimpses of these workshops in operation. They show men dragging sledges loaded with stone, others pouring water before them to reduce friction, and craftsmen carving delicate statues under open skies. In some scenes, copper saws are depicted as large semicircular tools held by multiple workers, suggesting cooperative operation. The imagery confirms what the stones already tell us, that Egypt's strength was not in its kings, but in its systems. In the workshops of Memphis, smelters glowed day and night. The air would have been thick with smoke and the metallic tang of molten ore, bellows pumped by foot-powered flames that reached temperatures above 1,000 degrees Celsius, hot enough to liquefy copper. The molten metal poured into molds with ritual care, accompanied by prayers to Ptah, the god of craftsmen and creation. For these people, metallurgy was sacred. To shape metal was to imitate the gods, to transform chaos into order through fire. And so they built not just tools, but a philosophy of creation. The workshop became a reflection of the cosmos, a place where matter was reborn through heat, where form emerged from formlessness. The Egyptians did not separate science from spirit. They saw both as aspects of the same eternal principle. Every hammer strike, every chisel mark, was an invocation of that unity. Modern engineers studying these ancient methods often speak with quiet awe. They recognize the same logic that governs machines today: the reduction of friction, the conversion of energy, the optimization of effort. But in Egypt, these principles were expressed in flesh and stone, not steel and steam. The workshop was an extension of the human body, scaled up to monumental proportions. If one stands today among the remains of those quarries, it is impossible not to feel that presence. The grooves carved into granite still hold the rhythm of hands long vanished. The silence between them hums with a strange electricity, as though the stones remember the sound of their own making. These were the laboratories of a civilization that never needed gears or pistons to move the world. They built machines of purpose and endurance systems so elegant that they still function in our imagination. Under the weight of millennia, the dust of the workshop has settled, but the evidence remains undeniable. The Egyptians were not simply builders, they were experimenters, innovators, and engineers of the purest kind. Their genius was not in what they invented, but in how they understood the world as a workshop governed by order, rhythm, and transformation. And as the night deepens over the desert, one realizes that the echo of their labor has never truly faded. It vibrates through every measurement we take, every machine we build, every dream of permanence we pursue. The forgotten workshops of Egypt are not lost. They live on in the very idea of engineering itself. The morning sun spills across the cliffs of Tura, bathing the ancient quarries in light the color of honey. The wind carries a low hum, as if the earth itself is remembering. Between the jagged edges of limestone walls lie channels once filled with the sounds of chisels and human voices. The marks carved here tell a story older than empire. The Egyptians who worked these stones were not mere laborers shaping rock. They were engineers engaged in an unending dialogue between matter and mind. Fragments of copper chisels still lie embedded in the quarry floor. Some are warped by heat, others dulled by use, their edges rolled like waves. Each fragment is a fingerprint of intention. Metallurgical analysis reveals traces of arsenic, an accidental alloy that strengthened copper beyond its natural softness. This subtle discovery reshapes how we understand their craftsmanship. The Egyptians did not stumble upon hard metals by chance. They learned to control the chemistry of fire and ore with exquisite precision. In doing so, they turned the elements themselves into collaborators, The logistics of this ancient industry were staggering. To feed the monumental projects of Memphis and Giza, thousands of workers operated in perfect coordination. Each team specialized in one task: quarrying, transport, shaping, polishing. Records on temple walls describe rations of bread, beer, and dried fish distributed daily, a system so organized it rivals modern supply chains. The ancient engineers of Egypt built not only monuments but processes. They invented systems of accountability, distribution, and resource management, centuries before any formal science of industry existed. When the great blocks were released from the bedrock, they were dragged by teams of men over wooden sledges. The desert sand, when dry, would seize against the runners. To overcome this, the Egyptians discovered a simple but profound solution. They poured water ahead of the sledges. Modern physics confirms that a thin layer of moisture reduces friction by half. The Egyptians knew this through observation and practice. They understood the physics of their world without naming it. Their machines were human, their power derived from understanding rather than invention. Near the village of Hatnub, a newly discovered ramp system carved into limestone provides further evidence of their mechanical genius. The ramp is flanked by stairways on either side, lined with post holes that once held wooden poles. Ropes looped around these poles created a primitive but effective pulley system, multiplying force through simple geometry. By alternating tension and release, teams could move massive blocks up steep inclines with precision. This was not myth or magic. It was applied engineering, as elegant in its simplicity as any modern machine. The same ingenuity extended to the carving of stone. Tubular drills found at Giza, Abydos, and Saqqara show evidence of rotation achieved through bow mechanisms powered by cords of twisted sinew. The drills were tipped with bronze or copper and used sand as an abrasive medium. As the drill turned, grains of quartz carved microscopic spirals into granite. Over hours, days, and weeks, a hole would emerge, perfectly cylindrical, with grooves so regular they seemed machined. Such precision could not be the product of guesswork. It required measurement, patience, and a deep knowledge of material resistance. Yet, even with these explanations, some questions remain unanswered. How did they maintain such uniform pressure during drilling? How did they align massive blocks over distances measured in hundreds of meters, with errors smaller than the width of a human hair? These mysteries persist not because the answers are supernatural, but because the Egyptians mastered techniques of precision that we have only begun to rediscover. Their science was not written in equations, but in repetition, knowledge encoded in motion rather than words. Inside the tombs of artisans at Deir el-Medina, wall paintings show craftsmen sharpening tools, mixing pigments, and sculpting statues. The scenes are intimate, full of concentration and quiet pride. One image shows a worker holding a chisel against stone while another strikes it with a mallet. Their postures are exact, their angles perfect. The depiction captures not just labor, but discipline, a choreography of work refined through generations. These were the keepers of Egypt's mechanical wisdom, passing down methods that turned labor into art and art into engineering. Among their greatest achievements was the manipulation of scale. The same principles used to carve a scarab from lapis lazuli were applied to cutting obelisks from granite. The difference was only in magnitude, not method. Every monument was a magnified version of a craftsman's touch. The precision that aligned a pharaoh's statue also aligned the sides of the Great Pyramid. This continuity between micro and macro reflects a worldview in which scale was irrelevant. The universe itself was a workshop, and humanity its craftsman. In this philosophy, the act of creation was a form of balance. The Egyptians believed that Ma'at, the principle of harmony and order, governed all things. To carve a block, to polish a surface, to align a wall with the rising sun was to participate in cosmic equilibrium. Engineering was not separate from spirituality, it was its expression. The workers at Tura and Aswan were not anonymous slaves but initiates in a sacred science. Every stone placed, every groove carved, was an offering to permanence. Modern engineers studying the pyramids often speak of tolerance, the allowable error between ideal and reality. The builders of Egypt reduced that margin to almost nothing. Blocks weighing tens of tons fit together so perfectly that air cannot pass between them. The casing stones once reflected sunlight so brilliantly that the pyramids glowed like beacons visible for miles. To achieve this required more than strength. It required instruments of measure sighting rods, leveling basins, and plumb lines of astonishing accuracy. These were the quiet tools of genius, as powerful in their purpose as any engine. And yet, despite all that we have uncovered, their full process remains elusive. No single text describes how the Great Pyramid was built. No papyrus explains the calibration of their instruments. The knowledge existed not in words, but in the minds and bodies of those who practiced it. It was a living tradition, passed through demonstration, apprenticeship, and ritual. When that chain was broken, much was lost. What remains are fragments, chisel marks, broken saws, unfinished work, the fossilized traces of intellect in motion. But perhaps that loss is also a gift. It allows us to see the magnitude of their achievement through the lens of mystery. We stand among their quarries and workshops, surrounded by silence, and we can still feel the hum of precision in the air. These places remind us that technology need not be modern to be advanced, that intelligence does not depend on machines of metal but on minds that see structure in chaos. The Egyptians built their future from stone, fire, and will. Their tools have long since turned to dust, but their principles endure. In every modern workshop, in every blueprint, in every act of design, their spirit persists, the conviction that perfection is possible, that matter can be persuaded to obey thought. The wind moves across the quarry once more, lifting grains of sand that sparkle in the sunlight. Beneath those grains lie the remnants of an ancient machinery, a network of minds, muscles, and mathematics that once transformed the landscape of the world. And as we uncover their secrets one by one, we begin to understand that Egypt's forgotten workshop was never truly lost. It has simply been waiting for us to listen. The wind over Giza carries the scent of dust and time. It moves across the plateau like a whisper, stirring the edges of ancient stone. Here, in the shadow of the Great Pyramid, fragments of the past lie scattered in plain sight, bits of copper, shards of dolerite, remnants of drills and saws that once carved eternity into shape. To most visitors, they appear as ordinary stones, but to those who look closer, they are clues to a vanished technology. The lost tools of the pharaohs were not forged from myth or mystery. They were real instruments, precise and practical, shaped by centuries of observation and experiment. Archaeologists have uncovered hundreds of such artifacts around the pyramid sites of Giza, Saqqara, and Abydos. The most common are copper chisels, some worn to paper-thin edges, others broken clean in half, the metal brittle from repeated hammering. Their abundance suggests a vast scale of production and use. Yet, the stones they carved, granite, basalt, quartzite, are harder than copper itself. This contradiction has puzzled generations of researchers. How could a civilization armed with such soft tools shape monuments that still defy erosion after thousands of years? The answer lies not in lost metals, but in lost methods. The Egyptians did not rely on the sharpness of a tool, but on the interaction of materials. When a copper chisel struck granite, it was not the metal that did the cutting, but the sand applied between them. Quartz, harder than steel, acted as a natural abrasive. Each stroke of the chisel ground away a fraction of the stone's surface. Over time, the rhythm of those strikes achieved a polish beyond what most modern machinery can reproduce. The same principle guided their saws and drills, motion, pressure, and abrasive material, working together like gears in a silent machine. Among the most fascinating discoveries are the tubular drill cores found near Giza and Abu Sir. These stone cylinders, extracted from granite and basalt, bear spiral grooves that twist with mathematical precision. The pattern suggests continuous rotation under steady pressure. Modern reconstructions using bow drills, sand, and water can replicate similar results, though at a pace that tests human endurance. Each centimeter of progress could take hours. But the Egyptians were patient. They understood that the rhythm of time itself could be harnessed as a tool. The marks left by their drills are the fossilized memory of persistence. In the workshops of Memphis, ancient reliefs depict men using saws half as long as their bodies, guided by ropes and weighted pulleys. The saws cut through massive blocks with sand and water, acting as lubricants. Some scholars once dismissed these scenes as symbolic, but modern experiments prove their practicality. When the saw is moved in long, even strokes by 2 or more workers, the abrasive sand does the cutting while water clears debris and reduces friction. The result is a surface so smooth that light dances across it like water. These are not the products of fantasy, but of physics mastered through generations of trial and refinement. Other tools speak of equal ingenuity. Wooden mallets balanced in proportion to hand and arm length, plumb lines weighted with carved limestone, and measuring rods marked with divisions as small as a finger's breadth, all evidence of a mathematical precision that underpinned every act of construction. The surviving cubit rods, often carved from ebony or ivory, reveal a system of measurement that remained consistent for over 1,000 years. Each cubit was subdivided into palms and fingers, enabling workers to reproduce proportions across vast projects with near-perfect accuracy. Geometry was their universal language, and these rods were its alphabet. Hieroglyphic records add another layer to the mystery. In temple reliefs at Karnak and Luxor, scenes of workshops show smiths pouring molten metal, sculptors shaping stone, and carpenters building chests or boats. Among them appear curious instruments, weighted strings, curved gauges, and multi-toothed saws. Some even show circular tools that resemble early forms of lathes. Though no physical lathe from that era survives, depictions suggest the Egyptians experimented with rotational symmetry long before the Greeks formalized its principles. The statues of pharaohs and gods, perfectly balanced and smooth, may have been shaped using rotational methods, guided by sight, sound, and touch. There are other hints, too subtle to ignore. At the Serapeum of Saqqara, where massive granite sarcophagi lie buried in darkness, the interior surfaces are polished to mirror smoothness. Laser measurements reveal flatness within fractions of a millimeter across several meters of stone. Achieving this level of precision with hand tools seems impossible, yet the evidence stands. Engineers analyzing these surfaces note that they appear to have been ground, not merely chipped or hammered. Whether by continuous abrasion, rotating polishing tools, or an unknown system of mechanical assistance, the result testifies to knowledge as sophisticated as any modern craft. Still, to understand these tools fully, one must imagine not just their form but their rhythm. Every blow of a chisel, every pull of a saw, followed a pattern as deliberate as a heartbeat. The Egyptians worked in teams, synchronized by experience and by sound. The rhythm of hammers on stone may have guided their movements, creating a form of mechanical harmony. It was a kind of living metronome, a rhythm that transformed chaos into structure, raw material into form. This is why ancient builders were often called servants of Ma'at, for they literally brought order into being. When modern engineers attempt to replicate their methods, they often rediscover something deeper than technique. They find an attitude toward work that borders on meditation. In a laboratory at Cairo University, researchers once spent weeks reproducing a single section of drilled granite using only copper, sand, and water. The progress was agonizingly slow. Yet when they completed the experiment, the resulting grooves matched the ancient originals almost exactly. One of the researchers described the process as listening to the stone. That phrase captures the essence of Egyptian craftsmanship, not the domination of material, but cooperation with it. The Egyptians saw tools as extensions of the body. The hand became the lever, the arm, the beam, the hammer, an extension of intent. This understanding gave them extraordinary control. Their precision was not imposed but felt. Every sound, every vibration carried information about the material. The craftsman listened to those signals and adjusted his movements accordingly. In this way, even a simple copper chisel became a sensor, an instrument of feedback that guided the user through the language of resistance and release. Modern machines achieve precision through calculation. The Egyptians achieved it through attention. Their tools may have been simple, but the minds that guided them were not. They learned to read the language of materials as clearly as we read equations. When one stands in front of a temple wall carved with lines so straight they seem drawn by laser, one is not looking at the product of lost technology. One is looking at the culmination of human focus stretched across centuries. Yet, the true marvel is not the tools themselves, but the system that created them. The workshops, quarries, and construction sites of Egypt functioned as a single interconnected machine. Ore was mined in Sinai, smelted in the delta, and transported upriver to the stone yards of Giza. Tools were made, used, repaired, and recycled in a cycle as efficient as any industrial process. Laborers, artisans, and overseers each played their part in a machine powered by will and coordination. This was the mechanical genius of the Pharaohs, a civilization that built its technology out of people. The lost tools of Egypt are not lost because they have vanished, but because we have forgotten how to see them. They are hidden in plain sight, in the symmetry of statues, in the alignment of temples, in the perfection of stone joints. The copper, the sand, and the stone were only components. The true tool was the mind, sharpened by observation and honed by patience. As twilight falls over the plateau, the wind sighs again through the desert. It passes across the broken fragments of copper and granite, as if awakening something dormant. The tools that once shaped the world lie silent now, but their legacy remains everywhere in the gleam of a polished block, in the geometry of a wall, in the echo of a hammer that struck for eternity. Under the fading light, the stones seem to breathe. The ancient rhythm stirs again, faint but unbroken, as though the builders still work beneath the sands. Their tools may be gone, but their precision endures a language of order spoken through silence, written forever in stone. The night deepens over Saqqara, and the stars rise above the horizon with the same deliberate order that once guided the builders below. The air is still, cool, and filled with a faint shimmer of dust, as if the desert itself were made of time. Beneath that vast silence, beneath layers of sand and forgotten walls, lie the remnants of the greatest workshop the ancient world ever knew. In the tunnels of the Serapeum, archaeologists move slowly under flickering lights. Their steps echo against granite sarcophagi that seem far too immense to have been carved by human hands. Each box weighs dozens of tons, each lid carved to fit so precisely that no blade or light can slip between the two. When the surfaces are measured, the results defy expectation. Perfect symmetry across planes, mirror finishes inside chambers of darkness. How such precision was achieved remains one of archaeology's most humbling mysteries. Some claim these surfaces must have been shaped by lost tools, machines more advanced than copper and sand. Others insist that patience and repetition, not technology, are responsible. The truth, as always, likely lies somewhere between wonder and reason. The Egyptians did not have modern drills or diamond cutters, but they did possess something more powerful: the systematic knowledge of how matter behaves under pressure, vibration, and time. They built their own form of machinery from the tools of nature itself. Experimental archaeologists have tried to reproduce the granite work of Saqqara using reconstructed copper saws, dolerite pounding stones, and quartz sand abrasives. The process is laborious beyond measure. It can take a team of skilled workers weeks to carve a single depression deep enough to hold a hand. Yet, given time, the results are convincing. The same striations appear, the same curvature, the same fine polish born of water, sand, and persistence. This is the essence of Egyptian technology: precision emerging not from speed, but from the controlled repetition of effort guided by measurement. To understand this, one must abandon modern assumptions about efficiency. The ancient Egyptians did not divide time as we do. Their calendars measured eternity, not deadlines. For them, a decade was not too long to perfect a single chamber or statue. Each stroke of a chisel was an act of devotion, a motion repeated until the material itself yielded its secret. When we look at their monuments today, we see time compressed into form, centuries made solid, will transformed into architecture. At Giza, excavations near the pyramid's base reveal tool fragments, chips of dolerite, and residues of fine sand compacted by thousands of impacts. These are the fossilized remains of human energy, organized with mathematical precision. Every surface, every corner, reveals evidence of alignment, not random or approximate, but deliberate to a degree that borders on mathematical perfection. Modern surveyors have measured deviations so small that they fall within fractions of a single degree. To create such order by hand seems inconceivable until one realizes that each movement, no matter how small, was part of a greater pattern. Hieroglyphic inscriptions from temple walls describe artisans as those who open the stone. The phrase is more than poetic. It suggests that the Egyptians viewed their work as revelation, not construction. To open the stone was to free the form already hidden within it. Their tools were not weapons against matter, but instruments of translation. The chisel, the saw, the bow drill. These were means of communication with the physical world, guided by ritual and rhythm. In a tomb near Luxor, a painted scene shows two men operating what appears to be a large saw fixed to a wooden frame. The saw cuts through a massive block, while another man pours water into the groove. The depiction is strikingly accurate. It shows tension ropes keeping the blade straight and a counterweight maintaining pressure. This is not symbolism. It is documentation, a visual record of mechanical understanding centuries ahead of its time. The Egyptians may not have had machines powered by engines, but they mastered the same principles that govern them: force, friction, and equilibrium. Further north, in workshops at Abydos, archaeologists found polished diorite bowls whose inner curves are so smooth that they seem lathed. Some have concentric rings, perfectly, even from rim to center. Replicating such symmetry by hand would be almost impossible. Yet, when similar vessels are reproduced using rotating wooden spindles driven by bowstrings, the ancient precision begins to make sense. The Egyptians likely used simple rotational devices, perhaps rope-driven lathes, operated by teams of craftsmen. The principle was elegant: stone-mounted, bow-drawn, sand and water applied, and rotation maintained until the material surrendered its shape. From this, the line between sculpture and engineering disappears. Even more intriguing are the stone cores found at Abu Rawash and Abu Sir, some showing feed rates suggesting remarkable control. Engineers who study these artifacts note that the spiral grooves display consistent pitch, implying uniform rotation under constant pressure. Whether achieved by human rhythm or mechanical leverage, the result is undeniable: an understanding of motion as a form of measurement. The same logic that drives our machines of today guided their hands then. The Egyptians did not separate art from science, nor ritual from engineering. To carve was to calculate, to measure was to worship. The geometry that aligned their temples with the stars was the same that governed their tools. Each statue, each wall, each sarcophagus was built upon ratios that mirrored the heavens. To them, symmetry was not merely aesthetic, it was divine order made visible. The craftsman was not a worker, but a priest in service to that order. Modern technology has only begun to appreciate the full extent of this sophistication. Scans of unfinished work at Aswan show experimental cuts and discarded blocks with markings that suggest test measurements. The builders were learning through iteration, refining methods over generations. Their workshops functioned as laboratories, places where ideas took physical form. They experimented with materials, developed standardized dimensions, and achieved results reproducible on monumental scales. The lost tools of the pharaohs were therefore not individual objects but systems of knowledge. The chisels and saws were merely extensions of a mental architecture, a structure of observation, geometry, and patience. What made these tools powerful was not their composition but their coordination. When thousands of hands moved in harmony, guided by principles older than writing, they became something greater than technology. They became the mechanism of civilization itself. At night, when the wind sweeps over the Giza plateau, the sound it makes is hauntingly familiar. It moves through the cracks of the stones like the breath of an old machine idling in sleep. The pyramids, temples, and tombs that remain are not static monuments but components of a system still alive in the imagination of humanity. The copper, the sand, the water, these were its gears. The people were its energy, and the rhythm of their labor was its heartbeat. In rediscovering their tools, we rediscover that heartbeat. We realize that technology is not only about invention but about alignment, the alignment of will, knowledge, and matter. The Egyptians achieved that harmony long before the word engineer existed. Their lost tools were not lost at all. They remain in every hand that measures, every mind that designs, every heart that seeks to build something that endures. As the stars shift above the desert, the last light touches the horizon, and the stone glows faintly one final time before the night consumes it. The silence that follows is not emptiness, but completion. The tools of the Pharaohs rest where they were left, still sharp in spirit, still waiting for us to understand. The wind softens across the plateau as night gives way to the pale light of morning. The shadows of the pyramids stretch long across the sand, their angles carved not only by stone but by memory. Beneath this light, the ruins of workshops and tool pits begin to reveal their quiet order. Here and there lie the copper remnants of chisels, fragments of dolerite pounding stones, and broken drills buried in sand like the fossils of an age when the earth itself was the canvas of invention. As archaeologists sift through these relics, the image of Egypt as a land of divine magic gives way to something far more human, a civilization of precise thinkers. The real mystery is not what tools they used, but how completely they understood the materials around them. Every fragment tells the same story. A harmony between intention and matter, a discipline that made their world function like a living mechanism. Recent discoveries have added further depth to that picture. In a work site near the Red Sea, researchers unearthed fragments of copper saws alongside small piles of fine quartz sand. The mixture still contained traces of water and mineral residue, preserved by dryness. When the sand was examined under a microscope, its grains showed patterns of wear consistent with continuous vibration. Each tiny groove on those grains was the mark of a machine that had no moving parts, the human body repeating the same motion through hours of controlled labor. From such repetition came results that appear miraculous only because our attention has grown impatient. In another excavation near Abydos, a cluster of stone bowls and vases was found stacked beside what appeared to be an ancient lathe bed carved into limestone. The indentation bore parallel scratches, spaced evenly along its curve. When experimental archaeologists built a wooden version of that same setup, a rotating spindle turned by a bowstring, they recreated the exact patterns found on the bowls. The rotation was smooth, the pressure constant, the symmetry perfect. What had seemed impossible became visible again through imitation. In rediscovering how they worked, we uncover not mystery but method. The same principle extends to the great works of architecture. The alignment of the pyramids, temples, and causeways was not achieved by chance or mysticism, but by instruments designed for precision. Archaeological surveys reveal the use of water-filled trenches to establish level ground and plumb lines weighted by stone to define true verticals. The accuracy achieved through these techniques is astonishing, deviations so small that even laser measurements barely detect them. When one imagines thousands of such measurements coordinated across kilometers of construction, it becomes clear that the ancient Egyptians had created something akin to an industrial standard. They had transformed architecture into measurement itself. Every generation refined these techniques further. The workers of Saqqara perfected tubular drilling. The masons of Giza mastered limestone casing. The sculptors of Thebes developed smoothing and polishing methods that reflect sunlight like mirrors. Each advance built upon the memory of the last. The continuity of this progress reveals the presence of an organized knowledge network, a guild system of learning and preservation. There were no universities, no printed manuals, only masters teaching apprentices through demonstration. Yet the results rival the output of modern factories. Hieroglyphic scenes carved deep into temple walls often depict this process with reverence. Rows of craftsmen bend over their work, each tool glinting under the imagined sunday. Supervisors stand behind them with measuring rods, confirming angles and lines. Priests oversee the process, linking labor with ritual. To the Egyptians, to build was to sanctify. The chisel was an offering, the hammer a hymn. Their workshops were temples of transformation, where stone became divine geometry. When modern engineers reconstruct these scenes in laboratories, they begin to see the same relationships that define our machines today. Each worker was a gear, each tool a lever, each team a subsystem of a greater mechanism. The machine was not made of iron or wood, but of human rhythm, coordination, and shared purpose. It was self-correcting, self-sustaining, and capable of achieving accuracy far beyond what any single craftsman could accomplish alone. This realization reframes what we mean by lost tools. The tools of the pharaohs were not lost because they vanished. They were lost because the systems that used them ceased to exist. When the central organization of Egypt fragmented and knowledge passed from one dynasty to another, the continuity of training faltered. Skills that once required generations to master disappeared within decades. The copper chisels rusted, the dolerite stones were abandoned, and the rhythms that kept thousands in motion fell silent. What remains are echoes, traces of a technology of organization, not of hardware. Yet the spirit of that system lingers. Every time a modern builder checks a level, every time a craftsman feels the resistance of a tool and adjusts his pressure instinctively, he repeats what those ancient engineers once knew. The connection between hand, mind, and material is timeless. It is the same energy that raised stones into pyramids and temples, that turned sand and copper into instruments of near-perfect geometry. As twilight returns to Giza and the first stars appear, the desert cools and the stones begin to release the heat they have stored through the day. The air shimmers faintly, and for a moment, the entire plateau seems alive with memory. The copper glints under the fading sun, the sand shifts softly, and one can almost hear the ghostly rhythm of chisels and saws, the mechanical music of the pharaohs. Those tools may now lie buried, but their purpose endures. They remind us that technology is not defined by metal or electricity, but by understanding the ability to see pattern in the chaos of matter, to shape it through will and repetition. The lost tools of Egypt were never merely physical. They were mental instruments that transformed imagination into structure. And as the last light fades over the desert, that realization bridges us to what comes next. For the real machines of ancient Egypt were not tools or temples, or even the pyramids themselves. They were the systems behind them, networks of people, processes, and mathematics that turned the Nile Valley into the first great engine of civilization. Morning breaks over the Nile, with a pale gold light that spills across the water like molten metal. The river flows as it has for millennia, carrying with it the silent memory of the civilization it once sustained. Along its banks, long before the word factory was ever spoken, Egypt had already built one. Not a building filled with machines, but a living network of quarries, workshops, and transport lines that functioned with the precision of clockwork. The entire Nile Valley was an engine, and every citizen a moving part in the machinery of creation. To build the pyramids, the temples, and the colossal statues that still dominate the horizon, Egypt required not only tools but systems. The organization behind these works was so advanced that even modern engineers marvel at its scale. Stone was quarried hundreds of kilometers away, transported by barge against the current, cut and fitted at Giza, with tolerances that rival modern machining. Every movement of material was calculated, recorded, and repeated with consistency over generations. The pharaohs ruled not through mystery, but through management. At Aswan, the granite quarries roared with labor. Thousands of men chipped away at the bedrock, guided by overseers who marked each section with red pigment. Each block destined for the north was numbered, shaped, and inspected before transport. Wooden rollers, sledges, and rope systems transformed the quarry into a mechanical landscape. When the flood season came, the blocks were floated down the Nile on barges whose hulls were designed with astonishing hydrodynamic understanding. Paintings and reliefs show entire fleets of these ships, lined with oars, sails, and ballast systems that kept their precious cargo stable, even against the current. At the receiving end of this operation, near the Giza Plateau, another world awaited. The workers' village, discovered and excavated by archaeologists in recent decades, reveals an infrastructure capable of sustaining thousands of people with food, tools, and shelter. The remains of bakeries, breweries, and granaries tell a story of industrial-scale logistics. Massive ovens baked bread in quantities that could feed an army. fish, beans, and dates were distributed daily according to precise rations. Clay seals and hieroglyphic tags recorded deliveries, quality checks, and storage cycles. It was bureaucracy in its earliest form, the heartbeat of a factory that ran on human discipline and collective will. The sheer organization of the Giza complex defies the myth of slaves toiling under the lash. The workers were skilled specialists, artisans, and engineers who lived in planned housing with drainage systems and streets aligned to cardinal directions. Inscriptions on pottery shards record their team names groups with titles like the Drunkards of Menkaure or the Friends of Khufu. These were not the names of slaves, but of professionals bound by pride and identity. Their work was organized in shifts, with rest periods and rotation schedules to maintain precision and morale. The pyramids were not built by chaos, but by synchronization. The transport systems that linked quarry to site were themselves feats of engineering. Wooden sledges moved stone across compacted sand, lubricated with water to reduce friction. Teams coordinated their pulls to the beat of chants, the sound carrying across the desert like a mechanical rhythm. At intervals, ramps built of limestone chips and mud brick provided gradients for raising blocks to higher levels. Some of these ramps curved around the pyramid's base in gentle spirals, others ascended straight up its flanks. The evidence suggests a hierarchy of methods, an evolving series of mechanical experiments on a continental scale. Even more remarkable was how the Egyptians planned these operations. Archaeologists studying red ochre markings on stones at Giza have discovered mathematical notations, symbols representing angles, weight measurements, and alignment data. The precision with which these were applied indicates that foremen carried standardized measuring tools and knew how to translate design into construction. What we are witnessing through these markings is the birth of project management. Each task, each load, each distance was calculated in advance. There was no guesswork, only process. In essence, the ancient Egyptian construction site was an early assembly line. Raw material entered at one end of the system, and finished architecture emerged at the other. Workers specialized in tasks, cutters, haulers, polishers, masons, decorators, supervisors ensured continuity and timing. Priests conducted daily rituals that mirrored quality control, sanctifying each stage of progress. The rhythm of work and worship kept the system stable. The pyramids rose not by miracle, but by scheduling. The true power of this organization lay not in machinery, but in mathematics. The Egyptians understood proportion intuitively. Their designs were rooted in simple ratios that repeated across scales, allowing them to predict the behavior of structures under weight and time. The ratio of base to height in the Great Pyramid is not arbitrary. It encodes the relationship between circle and square, between earth and sky. Such precision required not just faith, but knowledge, a system of numbers that governed every task from quarrying to carving. Their mathematics was a language of motion, and through it, the builders translated vision into mass. In the bread-baking complexes near Giza, archaeologists have found hundreds of clay molds, each identical in shape and size. The same molds were used repeatedly to bake loaves for thousands of workers. This was mass production in the truest sense. The same principle applied to tool-making, where molds cast copper chisels by the dozen. When tools dulled or broke, they were melted down and recast, closing a cycle of material efficiency worthy of any modern factory. Nothing was wasted. Every object, every movement, had a purpose within the grand design. The logistics extended beyond the construction sites. Along the Nile, depots stored grain, copper, wood, and rope in quantities that could support years of continuous work. Scribes maintained inventories with reed pens and ink, their calculations preserved on limestone flakes and papyrus scrolls. The records they kept are among the earliest examples of systematic accounting. In their careful handwriting, one can almost hear the hum of the factory, the steady pulse of order turning chaos into monument. The workers themselves were not merely laborers but parts of a social machine. Their housing blocks were arranged by rank and occupation, forming neighborhoods of specialized function. Doctors treated injuries, cooks prepared measured rations, and overseers trained replacements to maintain continuity. The system anticipated everything, fatigue, illness, supply shortages, and adapted without losing rhythm. What began as architecture became governance, and what began as governance became a model for civilization. To call these operations factories is not metaphor but truth. A factory is a place where raw material becomes organized matter through repeatable process, and that is precisely what Egypt had achieved. Their product was not iron or cloth, but eternity itself, structures that still stand after thousands of years. The Great Pyramid is less a monument and more a machine that assembled itself through time, its gears made of people, its power source, the Nile, its blueprint, the cosmos. And when we step back from its shadow and look again at the vast sweep of the desert, we see not emptiness, but a system frozen in stone. Egypt's factories have long since fallen silent, but their order remains visible in every block, every angle, every measure. The ancients built not only with tools, but with ideas so precise they still echo in the foundations of our science and industry. As the light fades from the plateau and the last workers return to their villages, the air grows still again. The river glows red in the sunset, and for a moment, the world seems to pause. It is here, in this stillness, that one understands the genius of Egypt, not in its kings or gods, but in its organization. The machines of stone were not powered by metal or steam. They were powered by unity, by rhythm, by the shared pulse of thousands working as one. The true factory of Egypt was not built on the ground, but in the human mind, an idea that order could be made eternal. Machines may not have been made of metal, but systems were the true machines. And within those systems lay secrets even deeper, the power that may have pulsed beneath the pyramids themselves. Night has fallen over Giza. The desert exhales cool air, and the stars appear one by one above the black silhouette of the Great Pyramid. From a distance, the monument looks still, but beneath its vast geometry something stirs, not movement, but the quiet pulse of energy preserved in stone. For centuries, the question has lingered in every explorer's mind. What lies beneath these colossal shapes? What purpose did the hidden chambers and shafts serve? Were they tombs alone, or did they embody something greater, a machine powered by gravity, light, and the will of a civilization? Deep within the heart of the pyramid, corridors descend into darkness. The temperature falls sharply, and the air grows heavy with the scent of limestone. The walls seem to hum faintly, as though resonating with the footsteps of those who enter. At the core lies the king's chamber, lined with massive granite blocks transported from Aswan more than 800 kilometers away. Above it rise 5 relieving chambers, stacked like layers of protection, each sealed since antiquity. For centuries, explorers believed this to be the deepest secret of Giza, but in recent years, science has revealed otherwise. In 2016, the Scan Pyramids project began a series of investigations using muon tomography, a technique that reads the invisible rain of cosmic particles that constantly pass through the planet. Detectors placed inside the pyramid recorded how these muons scattered, revealing densities within the structure. Where more particles were detected, there must be less matter of void. After months of data collection, the results astonished the world. Above the Grand Gallery, a vast cavity appeared on the scans, a space larger than any known chamber. Its dimensions and position suggested design, not accident. Something was hidden there, sealed for millennia. No one yet knows its purpose. Some propose that it is structural, a space left to relieve weight and prevent collapse. Others believe it was intentional, perhaps a symbolic chamber, or even part of a mechanical system that once animated the pyramid itself. The idea may sound fantastical, yet within the precision of this monument, nothing seems arbitrary. Every angle, every corridor, every shaft appears to serve a purpose. The alignment of the pyramid with true north, accurate within a fraction of a degree, suggests an understanding of motion, balance, and energy that transcends mere ritual. The shafts leading from the king's and queen's chambers to the pyramid's exterior were once thought to be symbolic pathways for the pharaoh's soul to ascend to the stars. But when modern instruments mapped their trajectory, something remarkable emerged. Each shaft points to specific stars associated with the Egyptian afterlife Orion, linked to Osiris and Sirius, the star of rebirth. Yet their angles also serve an engineering function, allowing air to circulate, relieving pressure, and equalizing temperature between chambers. Spirituality and physics converge in the same design. The concept of power in ancient Egypt was never limited to authority or electricity. Power was harmony, the alignment of natural forces into functional unity. The pyramid embodies this principle. Its mass channels weight downward while maintaining internal equilibrium. Its angles distribute sunlight, wind, and temperature evenly. When sunlight strikes its sides at dawn and dusk, thermal gradients generate faint air currents through the shafts, causing pressure shifts that subtly resonate within the chambers. In this sense, the pyramid behaves like an enormous natural instrument, a harmonic structure interacting with the environment around it. Researchers have found that the king's chamber, when struck with sound at certain frequencies, vibrates in resonance. The granite blocks, dense with quartz, respond to vibrations in measurable patterns. Sound waves amplify within the room, forming standing frequencies that sustain for several seconds. Whether this effect was intentional remains debated, but the precision of the chamber's dimensions suggests it could not have been coincidence. The ancient builders may have known that geometry could shape sound, just as it shapes light and shadow. Ancient texts often describe the pyramid not as a tomb, but as a house of energy, a phrase that resonates with this discovery. While the word energy may not have carried the same meaning then, the idea of balance between forces light and darkness, earth and sky, matter and spirit, was central to Egyptian thought. To build such a structure was to stabilize those forces, to bring the chaos of the world into alignment with order. The pyramid was not a machine in the modern sense, but it was mechanistic in its perfection, a geometry designed to harness the eternal. Far below the visible plateau, beneath layers of sediment and limestone, archaeologists have discovered tunnels and cavities that once connected the pyramid complex to the Nile. Some lead toward what appear to be water channels. When the river flooded each year, these channels filled and receded in cycles that matched the construction seasons. It is possible that water pressure was used to float blocks or assist in lifting them. Some researchers even propose that such systems continued to function after construction, regulating temperature or movement within the pyramid's base. This interpretation transforms the monument from static tomb to dynamic system. It suggests that the pyramid interacted with its surroundings, a machine of balance, driven by water, air, and sunlight. The same civilization that mastered quarrying, metallurgy, and transport may also have experimented with natural energy flows. Their machines were not engines of steam or metal, but symphonies of stone and environment. What modern science calls sustainability, the Egyptians called eternity. They built not for decades, but for ages. Their materials were chosen not for convenience, but for permanence. Granite's crystalline lattice resists decay. Limestone breathes with humidity, expanding and contracting with temperature, like the skin of a living organism. The combination of these materials created a self-regulating structure, able to endure sandstorms, floods, and earthquakes. In this sense, the pyramid is alive, a geological organism designed to last as long as the desert itself. Standing within the Grand Gallery, one can feel this balance in motion. The walls lean inward at precise angles, their symmetry broken only by the small steps that rise toward the king's chamber. The air feels thick, charged, as though vibrating at the edge of perception. Some researchers have noted that the gallery's shape amplifies sound in low frequencies, forming a resonance chamber. The acoustic energy, though faint, interacts with the quartz within the granite above, producing measurable electrical potentials. Whether accidental or deliberate, it reveals that the ancients understood something fundamental, that structure and vibration are inseparable. It is tempting to imagine these forces as part of an ancient mechanism, perhaps one that symbolized the cycle of creation and rebirth. The pyramid's internal shafts, ascending and descending, may represent the flow of energy between earth and sky. The cavities detected by muon scans could have served to channel weight, airflow, or even resonance. The builders may have viewed the pyramid not as a static structure, but as an eternal process, a machine of stone designed to keep the order of the cosmos mirrored on Earth. The more we study its inner geometry, the more it appears that the pyramid's true function was knowledge itself. It encodes the principles of proportion, astronomy, and balance in its every dimension. The distance between its base and apex mirrors the curvature of the Earth. The ratio of its height to perimeter approximates the relationship between radius and circumference. These are not accidents. They are mathematics carved into eternity, a silent equation expressing the unity between heaven and earth. The power beneath the pyramids, then, is not mechanical but conceptual. It is the power of coherence, the ability of an entire civilization to align thought, labor, and matter into one perfect act of creation. To build such a monument required faith not in gods alone, but in order itself. Every block, every angle, every shaft is a testament to that faith. And yet, the greatest mystery remains what lies beyond what we can measure. The voids revealed by modern scans are still unentered, their silence unbroken. They may contain nothing but air and darkness, or they may hold relics of an understanding we have yet to rediscover. The true machinery of Egypt may not have been made of copper or stone at all, but of ideas powerful enough to endure for eternity. These ancient mechanisms, whether of stone, sound, or mind, hint at something deeper still. For to build such structures was to challenge the limits of the possible, to engineer the impossible itself. The wind sweeps through the broken limestone at the edge of the plateau, carrying whispers of a time when the desert rang with the sound of hammers, saws, and human rhythm. The Great Pyramid rises above it all, its flanks still aligned to the cardinal directions with precision so uncanny that no simple explanation satisfies. How could people without iron, without pulleys or wheels strong enough to bear such loads, lift millions of stones each weighing more than a dozen tons? How did they position each block with an error smaller than the thickness of a human nail? These questions form the heartbeat of a mystery that has survived for more than 4,000 years. To build the impossible, the Egyptians had to master the physics of their world with methods both practical and poetic. Every detail mattered. Each block of limestone extracted from Tura or granite from Aswan was cut to a specific size, shaped for a specific layer. Archaeologists have mapped the sequence of blocks upward from the base to the summit and discovered a hidden pattern. The stones decrease in height but increase slightly in angle, compensating for the changing load as the pyramid narrows. This is not the mark of superstition, but of mathematical foresight. The builders understood not just what they were building, but how weight and stress would behave within it. Several theories attempt to explain how these blocks were lifted. The most famous is that of Jean-Pierre Houdin, the French architect who proposed that the pyramid was built from the inside out. According to this idea, a ramp spiraled within the structure itself, allowing workers to pull stones upward in stages, always staying within the pyramid's envelope. Computer simulations support the theory's plausibility, showing that such an internal ramp could accommodate the geometry and logistics without requiring impossible resources. If true, it reveals not only engineering brilliance but architectural elegance, a design that hid its own method within its form. Other researchers focus on counterweight systems that may have used water, pulleys, or sliding tracks to raise the stones. Ancient depictions of shaddufs, levered water-lifting devices, suggest that Egyptians understood mechanical advantage. Scaled up, such systems could lift weights by converting distance into force. Wooden beams, ropes, and rolling logs, aided by water lubrication, could create a primitive but effective elevator. The Great Pyramid's Grand Gallery may even have been part of such a system. Its ascending slope and grooves along the walls fit the geometry of a counterweight track. Whether this interpretation is correct or not, it reflects a civilization capable of converting gravity itself into an ally. To move such masses required more than strength. It demanded synchronization, the careful choreography of thousands acting as one. Teams of workers would haul a single block in unison, chanting to keep time. Supervisors measured distances with ropes marked in cubits, adjusting direction by sighting along poles. The sand beneath the sledges was moistened to half its natural friction. When modern physicists replicated this technique, They found that the optimal water content reduced resistance by 50%. The ancients did not need equations to prove it. They had centuries of trial and memory. Precision began long before the first stone was laid. The Egyptians surveyed their foundations using techniques astonishingly close to modern geodesy. They stretched cords soaked in castor oil to reduce slack and measured the level of the ground with shallow trenches filled with water, the first hydraulic leveling systems in history. The corners of the pyramid were aligned with the 4 cardinal directions using the stars of Ursa Major and Ursa Minor, observed at the instant of their alignment on the horizon. Modern reconstructions show that the builders achieved orientation accuracy within 3 arc minutes, a feat that would challenge even contemporary surveyors without optical instruments. And then there was the matter of scale. The pyramid's base covers more than 5 hectares, its perimeter stretching nearly a kilometer. Each side rises at an angle that reflects not guesswork but deliberate calculation. If the Great Pyramid was scaled up infinitely, its slope would meet at a point corresponding to the mathematical constant pi, the ratio between a circle's circumference and diameter. Whether coincidence or cosmic design, the relationship between circle and square encoded in its shape symbolizes harmony between heaven and earth. The structure is geometry turned into theology, mathematics serving divinity. To cut the stones that formed such a monument, the Egyptians used copper saws embedded with quartz sand. This combination, humble but effective, could slice through granite if applied with patience. The technique was slow but precise. Workers understood that cutting speed mattered less than accuracy. They used rhythmic motion and consistent pressure, learning to read the sound of the cut as it deepened. When modern craftsmen replicate this process, they describe the same sensation of vibration that guides the hand like a whisper from the stone itself. Perhaps the most astonishing evidence of their precision lies in the casing stones that once covered the pyramid. Made of fine white limestone from Tura, these blocks were polished until they reflected sunlight with mirror brightness. When they were intact, the pyramid would have glowed like a beacon, visible from miles away. The joints between these stones were so fine that even a thin blade cannot pass between them. Some gaps measure less than 1/50th of an inch, filled with gypsum mortar applied so evenly it seems fused with the stone. This level of craftsmanship required not just skill, but a culture of exactitude, a shared belief that perfection was sacred. For the Egyptians, perfection was not an aspiration but a duty. Every act of building mirrored the creation of the cosmos. The world itself, they believed, was constructed from chaos by divine measurement. To build the pyramid was to repeat that act, to reaffirm that order still ruled over disorder. In this sense, the engineering of the impossible was also a ritual. Geometry was prayer, balance was offering, and precision was devotion. The builders were not merely craftsmen, they were priests of stability. When one stands today in the shadow of the Great Pyramid, the scale of this devotion becomes overwhelming. The air is silent, but in that silence, one can almost hear the rhythm of their work, the low hum of thousands pulling together, the scrape of sledges over stone, the steady beat of copper against granite. The structure above is not only a monument to a ruler, but a frozen symphony of human coordination. Every block fits into a grand equation that extends from earth to sky. Modern engineers often describe their own work in terms of efficiency, speed, and function. The Egyptians spoke in terms of harmony, eternity, and order. Yet at their core, both languages describe the same pursuit, the shaping of the physical world by the precision of the human mind. When viewed this way, the Great Pyramid is not a relic of the past, but an anticipation of the future, the first machine built not from parts, but from principles. And still, its mysteries remain. The purpose of its hidden cavities, the exact path of its internal ramps, the full extent of its construction systems. These questions continue to inspire new generations of scientists, architects, and dreamers. Each discovery brings us closer to understanding how the impossible became real. But even when the last secret is revealed, one truth will remain. The real power of the pyramid lies not in its mass, but in its mind, the collective intelligence of a people who believed that nothing, not even the laws of nature, was beyond the reach of order. The secret of Egypt's machines may not lie in their tools or materials, but in their grasp of mathematics and geometry, the language through which they engineered eternity. The stars drift slowly over Giza, tracing arcs across the heavens just as they did when the first surveyors set their eyes upon them more than 40 centuries ago. The Great Pyramid glows faintly beneath the moon, its angles so precise that they seem less built than calculated. Every line, every shadow, every slope belongs to an equation written in stone. The ancients did not merely construct monuments, they encoded mathematics into the landscape. To understand Egypt is to understand that geometry was not their tool, it was their faith. The Great Pyramid stands as the purest expression of that belief. Its base measures 430 sides of a cubit, and its height once reached 280 cubits. Multiply that height by 2 and divide by the base, and the result is a value astonishingly close to the mathematical constant we call pi. Scholars still debate whether this was intentional or accidental, but the consistency across multiple pyramids suggests design. The builders may not have known the name of the number, but they understood its essence, the unity between circle and square, heaven and earth. Their geometry was not abstract, but lived. The Egyptians learned mathematics by observing the world, the flood patterns of the Nile, the curvature of the horizon, the movement of stars across the night sky. They measured time not by clocks, but by the shifting of shadows. They saw proportion everywhere in the cycles of the moon, in the shape of the lotus flower, in the length of their own limbs. Out of these observations grew a language of numbers that governed both their art and their architecture. The rope stretchers, known as the harpedanapte, were the first surveyors. They carried ropes knotted into equal segments, forming triangles that could be stretched to define right angles. This simple tool allowed them to lay out perfect rectangles on the ground, the foundation of every temple and tomb. The famous 3-4-5 triangle, still taught in schools today, was their discovery long before Pythagoras. By using this geometric relationship, they could define square corners with accuracy, measurable even now. The world's first builders were also the world's first mathematicians. Mathematics in Egypt was never divorced from spirituality. The same ratios that determined the dimensions of pyramids also shaped statues, jewelry, and hieroglyphic art. The golden ratio, that mysterious proportion found throughout nature, appears repeatedly in their work. The face of Nefertiti, the seated statues of Ramses, and the layout of Luxor Temple all conform to it. The Egyptians recognized beauty as balance, and balance as divine. They believed that to express Ma'at, the cosmic principle of order, one must build according to perfect proportion. In papyrus texts such as the Rhind mathematical papyrus, scribes recorded the calculations used for construction, trade, and astronomy. These documents reveal a sophisticated understanding of fractions, area, and volume. They describe how to measure pyramids, calculate slopes, and divide land after the floods. The writing is methodical, practical, but also poetic. One passage reads, "The measure of height and shadow is the path of the sun upon the earth." Even their equations carried the rhythm of philosophy. The builders of the pyramids used these mathematical insights not only to plan their structures, but to align them with celestial bodies. The Great Pyramid sides face true north, south, east, and west, with an accuracy unmatched for thousands of years. To achieve this, they observed the circumpolar stars, those that never set and marked the instant when they crossed a vertical line in the sky. The same alignment can be found in temples along the Nile, each oriented to the rising of specific stars or the solstice Sunday. These buildings were not simply places of worship, but instruments for measuring time itself. The Egyptians understood the cosmos as a clock. The movement of stars, the flooding of the Nile, the precession of the seasons, all were part of a vast and predictable pattern. To mirror that pattern in stone was to participate in it, to fix eternity within the world of change. The pyramid, therefore, was more than a tomb. It was a calendar of the heavens, a cosmic diagram where architecture and astronomy converged. Their measurements were grounded in the human body. The cubit, their basic unit of length, was the distance from the elbow to the tip of the middle finger. It was subdivided into palms and fingers, creating a scale both universal and personal. To build using the body as measure was to acknowledge the connection between humanity and the cosmos. Each temple, each obelisk, was thus an extension of the human form the body made eternal through proportion. Recent studies using laser scanning and digital reconstruction reveal how carefully those proportions were maintained. Even the smallest irregularities in the pyramid's blocks compensate for environmental effects: expansion under heat, contraction in cold, subsidence of the earth beneath. The builders understood that perfection is not static but dynamic. They calculated for change. Their mathematics was alive, adjusting to the rhythm of the world. Within this framework, mathematics became more than a science. It became a theology of structure. Every equation was a prayer, every ratio a hymn to balance. When a builder stretched his rope across the sand to mark a foundation, he was not only drawing a line but invoking the order that sustains the universe. The act of building was therefore an act of faith, a declaration that the cosmos itself was rational, measurable, and divine. The temples of Karnak and Luxor still echo this faith. Their pillars form grids of perfect symmetry. Their walls align to the rising and setting sunday. Light enters their halls only at specific moments of the year, illuminating altars in patterns that match the solar calendar. These alignments required generations of observation, the patient tracking of celestial motion through centuries. To us, they are monuments of stone. To their builders, they were equations brought to life. And always, behind this mastery, lay the conviction that understanding mathematics was the same as understanding creation. The Book of the Dead describes the god Thoth as the measurer of the heavens, the one who set numbers in their places. To emulate him was to share in his creative power. The pyramid, in this sense, was not built for the dead, but for the living, a testament to humanity's ability to translate divine order into matter. Even today, when modern scientists measure the pyramid's proportions with laser instruments, they find symmetries that seem impossible for a Bronze Age civilization. The base is almost perfectly square, with sides differing by less than a handful of centimeters over more than 200 meters. The angles converge toward the apex with a precision that exceeds tolerance standards used in modern architecture. Such consistency can only result from a unified mathematical system maintained over decades of construction. The Egyptians did not write their formulas in ink, but in stone. The proof of their equations is not found on paper, but in shadow, the way light slides down the pyramid's face at equinox, dividing it exactly in half. It is geometry transformed into experience. When one stands before it at that moment, watching the boundary between light and darkness hold perfectly still, one can feel the ancient mind at work, the union of intellect and devotion, science and spirit, measure and meaning. Their mathematics was never meant to end at the pyramid's edge. It extended into the heavens, mapping the movement of planets and stars. The calendar they built 12 months of 30 days each, plus 5 sacred days kept time with the rising of Sirius and the annual flood of the Nile. That synchronization between sky and earth defined their civilization. Every harvest, every festival, every act of construction unfolded according to it. To live in Egypt was to live inside a cosmic equation. And yet, for all its precision, their mathematics was never cold or mechanical. It was human. It spoke the language of observation and rhythm, not abstraction. The scribes who wrote their problems in ink did so by hand, with the same patience as the masons who carved hieroglyphs in stone. They saw no separation between calculation and art, between engineering and beauty. To them, a well-measured wall was as sacred as a hymn, a balanced ratio as profound as a prayer. The Great Pyramid, with its geometry tied to the stars, and its proportions reflecting constants that define our universe, stands as the ultimate synthesis of these ideas. It is a proof written not in symbols but in stone, a reminder that understanding the world is itself a form of worship. The mathematics of perfection was not confined to the living world. The same precision guided their designs for eternity itself, shaping the machines they built for the afterlife. Dawn touches the necropolis of Saqqara in pale gold. The long shadows of the step pyramid stretch across the desert floor like the hands of time itself. Beneath this monument, the first pyramid, The seed from which all others grew lie corridors and chambers that twist through the earth like veins of stone. It is here that the Egyptians first transformed architecture into ritual and ritual into mechanism. These were not mere tombs. They were machines for eternity, designed to preserve not only bodies but the very process of rebirth. The Step Pyramid of Djoser, built under the guidance of the architect Imhotep, marks the moment when Egyptian engineering became metaphysical. Before this, kings were buried in mastabas, flat-roofed tombs that symbolized stability. But Imhotep envisioned something new, a structure that would rise in layers toward the heavens, like a staircase to the stars. Each step represented ascent, a mechanical expression of resurrection. To build it, his teams used more than 2 million limestone blocks, each cut and placed with mathematical precision. Beneath the structure, they carved a labyrinth of tunnels, shafts, and sealed chambers that still astonish modern engineers. These subterranean systems were not simple passageways. They functioned like interlocking components of a great device. Some shafts descend vertically for more than 20 meters before branching into side corridors. Others align perfectly with celestial points above, allowing sunlight or starlight to penetrate at certain times of year. The arrangement suggests more than practicality. It reveals intention. Light and gravity, air and silence, all were integrated into a unified design that mirrored the journey of the soul through the underworld. Within these corridors, stone portcullises slide into place, sealing chambers with precision worthy of a modern vault. The mechanisms still survive, massive granite slabs fitted into grooves carved with millimeter accuracy. These slabs were raised during burial ceremonies, then lowered to lock forever, transforming the tomb into an impregnable chamber. The very act of sealing was both mechanical and spiritual, a ritual of closure symbolizing the transition from life to eternity. When the last portcullis dropped, the pharaoh's journey through the machine of death had begun. Centuries later, in the Great Pyramids of Giza, these mechanisms evolved into an even more sophisticated form. The passageways of Khufu's pyramid feature ascending and descending corridors, interlocked at angles that balance stress across the internal structure. The precision of their joints, the alignment of their axes, and the seamless transition between chambers all suggest an understanding of mechanical equilibrium. Some archaeologists interpret the Grand Gallery as part of a counterweight system, designed to raise or lower massive stones into position. Others see it as a symbolic ramp, guiding the soul's ascent through space. Both may be true, for in Egypt, symbolism and function were never separate. The sarcophagus chambers themselves were feats of engineering disguised as sanctuaries. The granite boxes found within are cut from single blocks, their interiors polished to mirror smoothness. The lids fit so perfectly that they form an airtight seal. When closed, they create a vacuum effect, a silence so deep that it absorbs sound. These were more than coffins, they were pressure chambers, designed to preserve the body and amplify the symbolism of transformation. Each detail, from the orientation of the lid to the thickness of the walls, reflects a harmony between material and purpose. In the Valley of the Kings, where later pharaohs carved their tombs into cliffs, the same principles persisted. The passageways descend in geometric spirals, drawing the visitor deeper into darkness until the burial chamber opens like a heart at the center of the mountain. The walls are lined with hieroglyphs describing the journey through the underworld, a cosmic map for navigation. Yet beneath the beauty of the art lies a structure that behaves like a labyrinthine machine. Every chamber serves a function: resonance, alignment, or containment. Some chambers were built to amplify sound, others to deflect weight or distribute airflow. The tomb was a living organism made of stone. In the burial chamber of Seti I, the ceiling is painted with constellations that mirror the night sky of ancient Thebes. The stars correspond to precise coordinates, forming a celestial diagram above the sarcophagus. The proportions of the room, the alignment of its axis, and the dimensions of the sarcophagus itself all fit within harmonic ratios, fractions of the same geometric constants that define the Great Pyramid. The architecture, in other words, was tuned. Each tomb was a frequency, and each pharaoh a note in the eternal symphony of creation. Egyptians believed that the soul, or Ka, needed mechanical assistance to pass through the thresholds of death. Their funerary texts describe doors that open by command, bridges that lift by power, and gates that turn upon their hinges of stone. These were not fantasies. Many tombs contain hinged doorways carved from solid blocks, balanced so precisely that they could swing open with a single push despite weighing hundreds of kilograms. In larger temples, pivoting doors were mounted on copper sockets, lubricated with animal fat, forming bearings that would not be reinvented for thousands of years. Even the gates of eternity had engineering behind them. The tomb was not only a resting place but a transformation engine. Its architecture reenacted the journey of Ra, the sun, descending into the underworld at night and rising again each morning. The shafts, ramps, and chambers formed the pathway of that cycle: descent, purification, rebirth. When the burial ritual concluded and the final seal closed, the structure itself became a machine of resurrection. The pharaoh, preserved in his sarcophagus, lay within a cosmic mechanism that promised renewal with each dawn. Archaeologists studying these tombs have noticed something curious about their acoustics. When sound is made within certain chambers, it echoes in harmonics that correspond to specific frequencies. In the Pyramid of Khafre, a low hum lingers long after a voice fades, vibrating through the granite like the resonance of a bell. The Egyptians may have used this property during rituals, chanting tones that matched the chamber's natural frequency. To them, sound was a form of power vibration as life. Each tomb thus became an instrument through which the soul could resonate with eternity. In the Temple of Abydos, a relief shows Osiris lying within a chest surrounded by hieroglyphs that describe the awakening by sound. Scholars interpret this as myth, but acousticians note that certain chambers nearby produce vibrations strong enough to alter air pressure. It is possible that rituals performed there used sound to evoke the presence of gods. Whether metaphor or mechanism, the principle is the same: transformation through vibration, a process that modern physics recognizes as resonance. The Egyptians did not separate technology from theology because they saw both as aspects of order. The mechanisms that sealed their tombs were extensions of the same principles that governed the cosmos. The stars revolved with perfect regularity, the Nile flooded in cycles, and so too did their architecture function by pattern and motion. Their machines for the afterlife were not powered by fuel or flame, but by alignment, the synchronization of geometry, sound, and belief. In later periods, these concepts evolved into more elaborate devices. The tomb of Amenemhat contains stone plugs that rolled into place through inclined shafts, locking the corridors behind them. Some of these blocks are so perfectly balanced that modern engineers have difficulty moving them even with advanced tools. The builders calculated weight, angle, and friction to ensure that gravity alone would activate the system at the proper moment. Once triggered, the mechanism could never be reset. Eternity was the design requirement. When one walks through these tombs today, lit by electric light instead of torch flame, the sense of machinery remains. The air feels measured. The walls hum faintly, and the geometry of the chambers seems to direct movement and perception with invisible precision. It is as though the architects built not for the eyes, but for the senses shaping space to control sound, temperature, and emotion. Every corridor leads with purpose. Every angle, every shaft, every echo is deliberate. The tomb operates like a great cosmic circuit, transmitting the pharaoh's soul toward immortality. The machines for the afterlife were the ultimate union of physics and faith. They harnessed natural forces, gravity, sound, light, and air to enact the drama of resurrection. Their efficiency endures because their principles were universal. A door that swings easily on its pivot, a shaft aligned to the stars, a resonance that magnifies a human voice, these are not accidents of artistry but expressions of deep understanding. The ancients knew that eternity could not be achieved through magic alone. It required engineering. As the desert wind sweeps across the necropolis and the sun climbs higher, the tombs once again fall silent. Their hidden chambers remain sealed, their portcullises locked, their echoes lingering beneath the sand. Yet within that silence, one can still sense movement not of gears or levers, but of thought. The machines of the afterlife are still running, powered by memory and light, performing the same task they were built for, transforming mortality into permanence. As centuries passed, Egypt's secret technologies evolved. The line between architecture and mechanism blurred, and the modern world began to rediscover what the ancients already knew, that the true machine of civilization is the mind itself. The desert never gives up its secrets easily. But in the last century, and especially in the last few decades, modern science has begun to pry open the long-sealed silence of ancient Egypt. Satellite imaging, ground-penetrating radar, and experimental archaeology have uncovered traces of a lost technological language, one written not in metal and machinery, but in geometry, balance, and human coordination. The deeper we look, the more we realize that Egypt's greatest achievements were not accidents of mystery or myth. They were the deliberate work of a civilization that understood materials, physics, and mathematics in ways that were both empirical and intuitive. Across the Nile Valley, teams of archaeologists and engineers have begun reconstructing the ancient methods. At Saqqara, researchers have recreated the tools used by the masons of Djoser: copper chisels, dolerite pounding stones, and bow drills tipped with quartz sand. Under controlled conditions, these replicas can cut limestone and granite with surprising efficiency. The marks left behind match those found on the original blocks, proving that the Egyptians' methods were not primitive improvisations but refined systems honed over generations. What once seemed miraculous now reveals the precision of science guided by patience. In Aswan's granite quarries, archaeologists have identified incomplete obelisks still attached to the bedrock. The walls of their trenches bear deep, curved scars, the result of pounding stones swung with rhythmic precision. By mapping these traces, researchers have determined that teams of workers rotated their strikes in perfect synchronization, carving out depressions that followed predictable arcs. Each groove recorded a human frequency motion turned into pattern, labor into geometry. This repetition was not guesswork. It was a controlled process optimized through centuries of experience. At Giza, other researchers are studying the logistics of transport. Experiments have shown that dragging massive stones across moistened sand reduces friction dramatically. When the moisture content reaches the right ratio, the sand stiffens just enough to prevent sledges from sinking while still lubricating their runners. Ancient paintings show workers pouring water in front of moving sledges, a detail once dismissed as symbolic. Now it reads as technical instruction. These people did not rely on brute force alone. They understood the physics of their environment down to the grain. The rediscovery of these principles has transformed the image of the ancient builder from mystic to engineer. In modern laboratories, mechanical engineers have built full-scale models of ancient tools, testing their performance with laser measurement. Copper saws embedded with quartz sand can indeed slice through granite blocks when operated at the correct angle and rhythm. Tubular drills, powered by hand bows, leave spiral grooves nearly identical to those found in artifacts at Abu Sir and Giza. The conclusion is clear. The Egyptians mastered mechanical efficiency long before the concept of the machine was ever defined. What makes this mastery so striking is that it emerged from observation rather than theory. The Egyptians lacked algebra and calculus, yet they achieved results that modern equations can describe with stunning accuracy. Their mathematics was geometric, visual, and physical, drawn from the real world rather than abstract symbols. They measured the motion of the sun, the flood of the Nile, and the cycles of the moon, then built systems that harmonized with those patterns. Every machine, every mechanism, every pyramid reflected the same principle. Nature is predictable, and through measurement, it can be guided. Modern technology is now being used to read this ancient technology. Muon tomography, the same cosmic ray scanning that revealed hidden chambers in the Great Pyramid, is being applied to smaller sites across Egypt. Beneath the sands near Abydos, scans have identified voids arranged in regular grids, possibly remnants of ancient workshops or storage halls. Ground radar near Luxor has traced long linear anomalies that may represent buried causeways connecting temples to the river. Each discovery hints at the scale of the industrial infrastructure that once existed here, buried under millennia of drifted sand. But the rediscovery is not only technological, it is human. Excavations at the workers' village near Giza reveal a level of organization that rivals that of modern engineering projects. Archaeologists have unearthed bakeries capable of producing thousands of loaves per day, breweries that brewed gallons of beer daily, and barracks housing skilled laborers, not slaves, but trained specialists. Each worker had a defined role within a vast production system. Scribes recorded quotas, foremen distributed materials, and supply chains stretched across hundreds of kilometers. In this sense, the pyramid was indeed a machine, a social one, powered by coordination rather than gears. The past 2 decades have also seen a surge in experimental archaeology. Engineers and historians have teamed up to reproduce the techniques of ancient Egypt, using only period-appropriate tools. In one project, a team managed to raise a 2-ton limestone block to a height of 15 meters, using a combination of levers, sledges, and counterweights. The process was slow but steady, and it worked. Another group recreated a working replica of an Egyptian wooden crane, demonstrating how ropes and pivot beams could lift obelisk sections with controlled precision. Each experiment confirms that the ancients achieved their feats not through mystery, but through mastery. Even sound, once thought to be purely symbolic in Egyptian ritual, is now being studied as a possible technological component. Acoustic engineers have analyzed the resonance of chambers within the Great Pyramid, the temples of Karnak, and the tombs of the Valley of the Kings. Many of these spaces vibrate at frequencies that amplify human voice, drum beats, and chanting. It is plausible that rituals were designed to exploit these effects, transforming architecture into an auditory instrument. In that sense, their machines extended beyond mechanics into psychoacoustics, a field only rediscovered in modern times. One of the most intriguing examples of ancient ingenuity lies in the Temple of Edfu, where inscriptions describe the House of the Falcon. The text mentions the great device that lifts the sky and the lever of the Sunday. For centuries, scholars dismissed these phrases as metaphor, but in light of recent discoveries, some now see them as coded descriptions of real mechanisms, cranes, counterweights, or solar instruments. The Egyptians encoded technical language in mythic form, merging poetry and engineering into one. Their gods were not abstractions but personifications of natural forces, gravity, light, motion translated into divine form. At the modern research site of Saqqara, archaeologists have reconstructed the full burial system of the step pyramid. By analyzing wear marks, pulley grooves, and tool fragments, they have identified the sequence of operations used to lower and seal the sarcophagus. The result is astonishingly efficient, a gravitational system that required only a few dozen workers to move blocks weighing several tons. Once the process was complete, counterweights automatically locked into place, sealing the chamber permanently. It was both ritual and automation, a mechanical act designed to last forever. These rediscoveries have reshaped the narrative of human progress. They remind us that technology does not always advance in a straight line. Sometimes it rises to great heights, then vanishes, leaving only silent evidence of its existence. The machines of Egypt were not lost because they failed. They were lost because they were buried both literally and metaphorically beneath the sands of time. Their principles survived only as symbols, encoded in myths and monuments, waiting for a civilization advanced enough to read them again. In laboratories and workshops across the world, engineers are now using modern tools to test ancient hypotheses. 3-dimensional scans of obelisks, blocks, and sarcophagi reveal tolerances finer than those of early modern machinery. Digital simulations of construction sequences confirm that internal ramps, counterweights, and sand-based braking systems could explain much of what was once considered impossible. What these models reveal, more than anything, is a mindset, a culture that sought harmony between nature and design rather than domination over it. Egypt's true technologists were not inventors in the modern sense, but harmonizers, people who learned to work with the laws of the world rather than against them. They saw mathematics not as a weapon, but as a bridge. They understood that the greatest power is not control, but alignment. Their machines were not made of bronze or steel, but of principle and rhythm. To rediscover them is to rediscover ourselves, our own capacity to turn curiosity into creation and imagination into permanence. As the excavators brush dust from carved stone and the scanners reveal the hollow heart of the desert, a new vision of Egypt emerges, not as a relic of superstition, but as a prototype of science. The same land that gave birth to geometry, astronomy, and engineering continues to teach us that the boundary between technology and philosophy is an illusion. The ancients did not build engines, they built ideas, and those ideas still move the world. The story of Egypt's machines does not end in its ruins. Beneath the surviving stone, beneath the silence of the desert, still lies the unfinished legacy of the first engineers, the blueprint of how civilization itself became a machine. The desert stretches to the horizon, an ocean of silence and memory. From above, the Nile cuts through the land like a ribbon of life, winding past temples, villages, and the skeletal remains of ancient cities. Somewhere beneath that sand lie the buried engines of civilization, not of iron or fire, but of thought. Egypt's machines were never meant to move, they were meant to endure. Every block placed at Giza, every wall at Luxor, every hieroglyph carved into granite forms part of a single system, one that still hums faintly across the millennia. Its power is not mechanical but intellectual, a network of relationships between human beings, the earth, and the stars. The Egyptians discovered something few cultures ever have, that true permanence lies not in materials but in proportion, not in force but in order. Modern science, for all its precision, often forgets this. We build for efficiency, for profit, for speed, but the architects of the Nile built for eternity. Their structures were equations written in stone, balancing gravity with geometry, sunlight with shadow, chaos with balance. Each temple was a clock, each tomb a compass, each statue a mathematical statement about the nature of existence. Their machines were civilizations in miniature, self-regulating, self-renewing, self-defining. Beneath the sands of Saqqara, beneath the bedrock of Giza, sensors continue to probe the dark. New cavities appear on the scans every few years, networks of tunnels, sealed chambers, symmetrical voids that defy natural formation. Some may hold relics. Others may be nothing but air trapped in forgotten corridors. But each discovery pushes the boundary of what we know further back. It reminds us that we are not uncovering a past world, but re-entering it. Every excavation is an act of translation. Archaeologists decode tools, walls, and dust as if they were language. The more they learn, the more the pattern repeats itself. Precision, proportion, balance. Whether carving a statue or aligning a pyramid, the Egyptians pursued the same principle: harmony. This is what makes their civilization feel both ancient and modern. Their temples may have been raised for gods, but their logic was scientific. They measured, tested, and refined, generation after generation. Their discoveries were not accidents of belief, but outcomes of method. Even now, the mathematical harmonies encoded in the Great Pyramid continue to echo through human thought. Its slope embodies the ratio of circumference to diameter. Its proportions reflect constants that define the universe itself. Its alignment with true north is so precise that it surpasses that of many modern observatories. And yet, it was built with nothing more than rope, stone, and human will. The true machine was not the pyramid, it was the society that made it possible. In this light, Egypt becomes a mirror. Its monuments reflect what humanity can achieve when knowledge, faith, and purpose move in unison. The workers at Giza were not anonymous laborers. They were parts of a living mechanism, synchronized by shared understanding. Their effort produced something beyond their own lifetimes, a structure that still stands when all memory of its makers has turned to dust. That is the ultimate function of Egypt's machines, to turn the fleeting into the eternal. As modern engineers study these monuments, they find lessons that remain astonishingly relevant. Sustainable design, renewable energy, and ecological balance all echo the same philosophy that guided the builders of the Nile. The pyramids breathe with the desert, expanding in heat, contracting in cold, maintaining internal equilibrium. Their materials are locally sourced, recyclable, and perfectly suited to their environment. They are not relics of a primitive age, but prototypes of an advanced one, monuments of ecological intelligence. The mathematicians and astronomers who once measured the heavens with ropes and sighting rods would recognize the precision of our telescopes and satellites. But they might remind us of something we have forgotten, that knowledge without purpose is only noise. The Egyptians' science was never separate from their spirituality. To measure a star was to participate in the divine. To cut a perfect stone was to affirm order in a world of chaos. In their hands, technology was not a means to control nature, but to align with it. There is a quiet moment that comes to every visitor who stands before the Great Pyramid. The desert wind pauses, the sunlight flattens, and time seems to dissolve. The structure towers above, both impossibly simple and infinitely complex. Its lines point to the stars, but its weight roots it deep in the earth. It embodies what all human achievement seeks: balance between the finite and the infinite. And in that balance, one begins to sense the legacy of those who built it. They did not write their equations in books, nor store their data in circuits. They encoded their knowledge in form and proportion, trusting that one day another civilization would read it. That civilization is ours. We are the inheritors of their experiment, the continuation of their machine. Our skyscrapers, our satellites, our networks all descend from the same impulse that lifted the stones of Giza, the desire to understand, to build, to endure. Yet the sands still hide more. Ground radar reveals patterns stretching for kilometers: buried causeways, sunken chambers, the faint geometry of lost temples. Each discovery expands the map of ancient Egypt, revealing a civilization far more interconnected than history imagined. From the quarries of Aswan to the tombs of Abydos, the same measurements repeat, the same ratios return, the same alignment to the stars persists. This is not coincidence, it is design. A grand plan written across the landscape, as if the entire civilization were one vast coordinated machine. When the first rays of sunrise strike the pyramid's eastern face, the stones glow with a warmth that seems alive. The shadow retreats, revealing angles so precise they could have been drawn yesterday. Time collapses. The builders are here again, their hands shaping the horizon, their eyes fixed on the stars. The same curiosity that drove them drives us still. We study their work not to worship the past, but to rediscover the future they once imagined. In the end, Egypt's machines were never meant to move mountains, they were meant to move minds. They proved that intelligence does not require iron, that progress does not demand haste, and that true power lies in understanding the rhythm of the universe. The pharaohs may have built their monuments for eternity, but the real legacy is ours to interpret. It is the idea that thought itself can be immortal. And so, beneath the stone and sand, beneath the silence of 4,000 years, something continues to function, a circuit of memory connecting the first engineers to the last. It hums not with electricity but with meaning. It is the machine of civilization itself, built from geometry, belief, and wonder. They built no engines, yet moved mountains. Forged no steel, yet cut granite. The machines of ancient Egypt were not gears and pistons but minds, united in purpose, precision, and timeless ambition.